So today we are going to discuss what is pericyclic reactions. So pericyclic reactions where the reactant goes to product via cyclic transition state. So these reactions are single step and concerted reactions. So meaning of pericyclic is around ring means so whenever R is going to form product so via cyclic transition state. So transition state must be cyclic. Then and then only we call this is a pericyclic reactions. So what is peri? Peri means around and cyclic means what ring. So what are the characteristics of these pericyclic reactions? So mainly pericyclic reactions are molecular reactions. So molecular reaction means whole molecule is involved in this reaction. That's why pericyclic reaction is called pericyclic reactions. So what are the characteristics of pericyclic reactions? The first characteristics is so these reactions are induced or initiated by heat or light. So these are induced or initiated by heat or light. That is we can start this reaction either heat or light. So whenever we start this reaction by light, so this reaction is called photochemical pericyclic reaction. So whenever we start the reaction or initiated with light, so this is called photochemical pericyclic reaction. So whenever we initiate this reaction by heat, or this is called thermal. This is thermal pericyclic reaction. Second characteristic is so these reactions proceed by producing cyclic transition state. So therefore this reaction is called pericyclic reactions. So these are proceeds by producing cyclic transition state. Therefore these are called pericyclic reaction. So here that is R is going to form product via cyclic transition state. The third important property is these reactions are single step and concerted reaction. So what is single step? That is one step reaction. And what is concerted reaction? So during the formation of product, the new bond formation and old bond cleavage takes place at a one time. So this reaction is called concerted reactions. So all pericyclic reactions are concerted reactions. So in transition state, if bond formation and cleavage takes place with equal rate, so this is called synchronous reaction. And if bond formation and cleavage takes place with different rates, so this is called non-synchronous reaction. So pericyclic reactions are synchronous reaction because in a transition state, so new bond formation and old bond cleavage takes place with a equal rate. So this bond formation and bond breaking takes place with what? Equal rate. So all pericyclic reactions are concerted reaction. So let me take you an example. So this is 1,3-butadiene 1 2 3 4. So this is pericyclic reaction. So whenever it is converted into product, but it goes through a cyclic transition state. Okay, so what is cyclic transition state? So this is a migration of these pi electrons and 1 2 3 4. So this is a transition state. Okay, so this new bond formation here at termini of what 1 and 4 and old bond cleavage or occurs at same rate. So this is a concerted, and this reaction step has what single step. So fourth characteristic is, so rate of reactions. The rate of pericyclic reactions are unaffected by nature of solvent and catalyst. Rate of pericyclic reactions unaffected by nature of solvent and catalyst. Okay, but other reaction, the rate of reaction is affected by nature of solvent like polarity and the catalyst. So in pericyclic reactions, the rate of reaction is not affected by nature of solvent and catalyst. The fifth characteristic is, so this reaction will not produce charged or neutral radical intermediate, but reaction may start with charged or radical species. So in pericyclic reaction, so in transition state, there is no formation of any charged particle, means carbocation or carbanion intermediate or any free radical. So other reactions, that is other than pericyclic reactions, so we consider what SN1 reaction. So there is formation of what carbocation at intermediate, and some of the other reactions is formation of what carbanion or free radical. But here in pericyclic reaction there is no formation of what any radical intermediate or what charge particle, but this reaction may start with charge or radical species. So meaning of what, that is whenever the reaction is goes to form product, so it either form what carbocation, carbanion or what free radical. But in pericyclic reaction, so there is no chance to formation of what such a charge or neutral radical intermediate. But these reactions are start with what charge or radical species. So let me take example of this. This is R and here this is positive charge. This is carbocation. Okay, so here, so what is transition state? So just I told you these are pericyclic reactions. So there is what cyclic transition state. So here this is delocalization of this positive charge, and it going to form what a product, this. The six characteristics of this reaction. Six characteristic. Pericyclic reactions are kinetically controlled reactions. Pericyclic reactions are kinetically controlled. So what is kinetic control? So these reaction product is form what fastly. ओके, ज्या रिॲक्शनमध्ये प्रोडक्ट हा फास्टली फॉर्मेशन होतो त्याला म्हणतो आपण कायनेटिकली कंट्रोल रिॲक्शन. अँड द कंडिशन्स विच आर गिव्ज राईज टू फॉर्म ए कायनेटिक प्रोडक्ट, दिस इज कॉल वॉट कायनेटिक कंट्रोल. ओके, जो रिॲक्शनमध्ये फास्टली प्रोडक्ट फॉर्मेशन होतं त्याला म्हणतो आपण कायनेटिक प्रोडक्ट. ओके, तर ह्या रिॲक्शनमध्ये त्याचं ट्रान्झिशन स्टेट काय असते, लोअर असते. सो एनर्जी ऑफ दिस ट्रान्झिशन स्टेट इज लोअर अँड यील्ड ऑफ प्रोडक्ट इज more. So these pericyclic reactions are kinetically controlled reactions. Next characteristics is, so pericyclic reactions are highly stereospecific. Pericyclic reactions are highly stereospecific. So why these reactions are highly stereospecific? So what is meaning of stereospecific reaction? So stereospecific means the stereoisomers of the same compound under similar condition produces stereoisomers of product. So such type of reaction is called stereospecific reaction. Or what is stereospecific? The stereochemistry of product determined by stereochemistry of what reactant. Okay, so let me give an example. So here this is diene, substituted diene. So this is RR reactant. So if we initiate reaction thermally, so what is stereochemistry of this double bond? So this is R and this HH, or this R and this bond. So these are opposites, so stereochemistry of double bond is what trans. Similar in this case, this is also a trans. Okay, so thermally if we initiate this reaction, so it form cyclobutene with stereochemistry is what 1 R H H R. So here new bond form. So stereochemistry of this sigma bond is, this is trans. Okay, because this R and this R is what opposite, so stereochemistry of what this is trans. So same compound, but stereochemistry of terminal RR is what different. So here the stereochemistry of this double bond is, the H is same side, this is cis, and this is HH are opposite, this is what trans. So in similar condition, the thermal, so it produce what? This is R, R, H and H. Okay, the stereochemistry of the sigma bond is what? Cis. So this is what a stereospecific, or this is called stereospecificity. Specificity. Okay, so just I define what is stereospecific. The stereoisomers of the same compound. So these are the compounds which are what? These are stereoisomers. Same compound, stereoisomers. So these are reacted under similar condition, produces what? Stereoisomer of the product. So this is what stereospecific reaction. Or the stereochemistry of product determined by stereochemistry of reactant. Okay. So next characteristic is what? That is 8 characteristic. The pericyclic reactions are common to unsaturated compounds. For example, olefins, alkynes, etc. Pericyclic reactions are common to unsaturated compounds. For example, olefins, alkynes, etc. So these are the 8 characteristics of pericyclic reactions.